Okay, yeah, because what we're suggesting is quite a kind of fairly big change from the norm of the way people are working generally, submitting sort of a single script-based model. We're really keen to get feedback from lots of different people and make the paper as accessible as possible. So we'll share the link to that shortly. Okay, so first of all, let's imagine you're building a model in R, and at its simplest, you might think of your model as just having a set of inputs that are fed into your model runs, and then you return a set of results. So really like stripping back all the complexity of what we do to this one really basic concept. Now, if you would want to build a model in R, for this, this example here is a healthy sicker model from Darth, you might structure that model something like this in terms of your file structure and the way that it works. So you might have a load of user inputs stored somewhere with the default stored somewhere. You might have some raw data, might be patient level data, might be something else, costing data, utility data, and then you'd have a series of functions or scripts. So you should have a series of functions or scripts that are stored somewhere in your file structure. And then your model is essentially just a series of functions which are both sequential. So for example, function 1 leads into function 2, but then also maybe nested. So you might have a series of nested functions like function 3 and 4, which are called by function 2. And so all of these functions combined lead to some set of results, and potentially from then on some visuals and tables. And then those are output. So, so our model is kind of constructed of this data, and then our code, our set of functions and scripts. And so by the time we've done this in R with our documentation of our functions and our data, our file structure might look like this. So we might have a folder that contains raw data and some default inputs. We might have a folder that contains all of our model functions, a folder that contains all of our documentation, a folder that contains some tests to make sure our functions are operating as we expect as we develop our model, and we don't break something inadvertently as we're working. And then we might have a folder that contains outputs. And the reason why that's in the dotted line is that to get those outputs, you can always run the model. So you don't necessarily have to have that kind of sent to something. So there's kind of an optional extra, I guess, to have the outputs actually in your code base. And by the time you've done this, you essentially have a package already. Like you're so close to a package at this stage that you may as well just structure it like this. Well, this would be my argument anyway. And so in a package structure, you have your package top level folder. You have a description of the package. That's one file, a namespace file, your R folder, which contains all your functions, a man folder, it's essentially a manual folder, which contains the documentation of each function, a data folder, which contains raw data and would, I would argue in this case, would contain also your default values that users might want to change, and a vignette folder, which might contain documentation of the higher level structure of the model. So your man folder might document what each function is doing, but then your vignette folder would be a broader kind of higher level, this is what I'm trying to achieve by putting all these functions together. So essentially your model documentation. And then a test folder containing tests. And so there's a really nice book, and Zach gave a really nice talk yesterday on how to kind of start constructing these packages. And so we've written this paper kind of guiding the user through a simple health economic model example, which has one function, calculate ISA, take some inputs. And we hope that that's kind of a useful addition to this R packages to make this R packages book very health economics relevant. So the benefits of this is that every package, when you pick one up, when you are reviewing one, every one will have a very similar structure. So it kind of improves familiarity between modelers with these different models. Documentation is done by default, and Wael will show a bit later how this works. And we saw a little bit of that yesterday with the help files. But because of the way packages work, you can check that your package meets certain criteria. And one of those criteria is that it's documented. So it kind of enforces good coding behavior through the use of Rhapsody. It also enforces this through unit testing, which is tests on specific subfunctions. So we can ensure that, and it gives the modeler some confidence that as they're developing their model, they're not breaking things that they previously built. And potentially more important from the perspective of those who are listening who are kind of from a regulatory background, so NICE, ZIN, CADS, others, it allows reviewers to test the tests rather than going into the equivalent of every single cell to make sure it's doing what it's doing. So what I mean by that is, has the modeler who submitted this model performed the necessary tests on each of their functions to make sure that function is doing what it's doing, and are we confident in it? And so it might be that where they've constructed that function themselves, they need to prove through the use of extensive testing that they've written that that function is doing the right thing. But if they've used somebody else's function, so potentially functions from ServHE or others, then they can rely on the testing that's already been done by the author of that function and the kind of validation and confidence of the wider community. So we hope that that will speed up model review. And the last benefit, which I'm going to talk about in much more detail now, is that once you've developed your model in this way, split it up into small kind of units, it's much more easy to distribute, to share code with others and for others to build upon what you've done. So therefore, we don't have to kind of continuously reinvent wheels, and we've got kind of a standard method that's easy to review and share. So you might think the first person to build a model in R on a specific topic would have to do a lot from scratch. They'd be writing a lot of their own code. If they then share that, say on GitHub, for example, as a package, the second person building that model has to write slightly less code. There'll be some functions that they can reuse, because a lot of what we do is bespoke and custom, but a lot of what we do is also quite standard, some of the methods that we use. And then person 3 can borrow stuff from model 1, model 2, and so on and so on. And so eventually, we're kind of sharing more and more of these kind of subunits, the function, which then gradually over time means that each person is making slightly less of their own code. And we see this already to a large extent from people who are using subfunctions from ServHE or FlexServe or whatever packages exist right now. But by kind of encouraging people to build their model as a package, we're just kind of extending that to a much broader scale. And so I guess my main argument is that you don't have to, when you're building your model, think of it as, I'm going to build this one-size-fits-all amazing thing like HESIM or HEMOD. There will be sub-functions, small units of pieces of work, calculations that you've done that other people will find useful. And so it's worth wrapping that into a package, because it's just not really that much work once you're already building a model kind of in good practice anyway. So the question we got kind of internally was, but won't we end up having to install a large number of packages? Because if every model is going to be built as a package and then we want to use one function from each model, aren't we going to have a huge number of packages being installed just to get 1 or 2 functions from each? So just like when you order something from Amazon, you get a huge box, tiny little object. That's Paul. So then there's the potential for industry, academia, consulting funded projects to collate package code, the really useful functions that we think can be used a lot from these different models, and build it into a kind of regulator preferred, and this is a very contentious word. We talked about validate package code, regulator approved. We weren't really quite sure on the wording here, it's a bit controversial. But what we're trying to get across is that once the community is happy with this package, that it does those units do what they say they're doing, there'll be a lot more confidence from those reviewing the model. So they might give it that function a light touch review. It's more a case of, is this being used correctly, rather than is the calculation correct? And the example I gave yesterday is nobody's reviewing the base R mean function. If you review a model in R, you're not saying, is the underlying code for the mean function correct? People just kind of take it as given that calculation is done correctly. And so then others, so for model 7, 8, 9, could tend to prioritize that package. And again, we see this already with ServHE and FlexServe and others. But it's kind of, the argument here is that if we are building our models as packages, we can start to develop kind of a circular iterative system where we're gradually, incrementally improving these this package, and that's growing over time. And it might be there's a kind of, it's not one package, it's topic related. There's a few related packages which everybody's kind of contributing to, and over time we're improving our code base. And so, yeah, we have an iterative process here. And so the question is, who's the best place to do this piece of work of iteratively improving? And I'd argue this community is kind of best place to do that, or at least kind of various people within this community leading a group of open source collaboration, kind of organizing this, but not necessarily doing it. It could be sort of an open source process where we're sort of all reviewing each other's work and gaining confidence in each other's work. So overall, our packages can serve as templates for best practice, making it easier to review and distribute code. But the crucial thing here is confidence, is getting people confident both using these packages, but also confidence in the individual functions of the packages themselves. And the benefits are enormous in terms of efficiency, not having everybody reinvent wheels, and therefore kind of standardizing best practice and disseminating best practice. And for the individual researchers involved, the kind of attribution in terms of citations of these packages is obviously beneficial for their profile. So in theory, it should work. So there's some previous examples of this. So for example, Fernando's paper on biomarker testing was constructed as a package, and the DARS group have a kind of template package already created, which is a really good guide, and that's kind of part of Fernando's kind of coding framework paper as well. It's described there. So I really recommend people take a look at that. But we've kind of written another parallel paper referencing that one, kind of guiding users kind of through the more basic process rather than using a template from somebody else, of just building the package kind of from scratch for their model. So rather than taking the template from DARS, which I think is fantastic and is one way of achieving this aim, is just to go ahead and start building these packages for your models yourself. So we guide the reader, and we'll share the Google Doc link, essentially from the basics of, I have one function that runs a very, very simple model. How do I build that into a package? So we hope that is a kind of a useful next step. And we really encourage people who think it sucks to let us know why, and we'll try and improve it. And if you want to be a co-author, I think you want to write a substantial piece on it, then more the merrier. So in that paper, we go through creating what we call Hecon pack, which contains a single function, calc-ISA. We show how to document it, how to run checks on it, talk about licensing, and at each stage of this, we link through to other resources for kind of finding out more how to do this. We show how to create the description file of your package, how to run tests on that function, what to do with internal and external data, and how to write your kind of vignette. And the example for this is made open source at Hecon pack, our package, and we show this tutorial paper with the Hecon pack package showing how to build that from scratch, but we also built, as a case study, the Six Sigma model into a package, showing how to kind of split the code from the data and hosting the parameter inputs on a remote server. And so I'm going to hand over to Wael, who's going to talk to you about that package and show a little bit of code.
Thank you, Rob. Hi, everybody. My name is Wael, and obviously I'm very delighted today to talk to you about our case study, the Six Sigma pack. And as just Rob said, the Six Sigma pack is an R package that we created as a case study in which we transformed a script-based model into a package-based model. And the idea was we wanted to use an existing model that everyone, or almost most people would know about, and switch it from a script-based model into an R package model to let people know the advantages of having such a having a model in a package. So currently the package is hosted on GitHub, and it's under the subdomain of the dark peaks analytics. As I say, you see there it's under the dark peaks. But before we move on to the package itself, let's remember, for those who have seen or have heard about the Six Sigma model before, how the script-based version of the model looks like. And this version of the script, this version of the model was published before by Eileen Kamp. Sorry if I'm pronouncing the name incorrectly, and her colleagues in 2018. And the script starts with with some user inputs, as you can see there, probability, the transition probabilities from some health states, cost and utilities associated with each of the health states of the Markov model. And for those who didn't hear about the Six Sigma model before, it's a 4-state Markov model where that is simulating a hypothetical disease with 2 levels of illness, sick and sicker, hence the Six Sigma name. So the script then moves on into defining a function. That function simply manipulates some of the transition probabilities, constructs a transition probability matrix, then defines or creates or constructs a Markov trace, and then uses that Markov trace in order to estimate the cost effectiveness outcomes, in this case, the costs and the qualities. And the script ends, as you say, see down there, by printing the results in form of a table. And obviously, to run the model, you simply source or execute the entire file so that it runs the model for you. So what we did was we used this diagram to explain what it did, and we essentially introduced 2 main functions: the run PSA and the run Six Sigma model. And as the name suggests, the run Six Sigma model is the function that essentially runs the model for you. And it does so by using a set of user inputs and by calling other sub-functions, namely the define transition matrix, which, as the script-based model does, it defines transition matrix, passes it through to the create Markov trace, which creates a Markov trace, and then together with the cost, calculate costs and calculate qualities, they do generate or calculate the cost effectiveness results. The other main function we introduced was the run PSA, which is rather a wrapper or a generic function that takes in any model. It prepares or generates probabilistic sensitivity analysis parameter configurations, and then calls in the run Six Sigma model in order to evaluate those parameter configurations. Now, after finishing, the run PSA produces results or stores results in a form of a table, which is then further processed by an interface function, which is called the plot PSA, which essentially transforms the outputs from the run PSA model into outputs that are suitable for consumption by a different function from a different package, which is called the Bayesian cost effectiveness analysis function by Luca. And then it spits out the figures and tables cost effectiveness PSA results. Now, I'll say one more thing before we move into seeing how we can install the package and then run the functions. Is that both main functions, the run PSA and the run Six Sigma models, do use either locally stored data or remotely securely stored data. And they do so by utilizing a helper function that we introduced, which is called the get model params function. And the get model params function is usually called internally by both functions if the user supplies the essential source URL, which is the address of the API in which the data is stored, and any required credentials or passwords to access that data. Now, to quickly show you, well, obviously I didn't have the courage to do this in front of you here, and I was worried about any technical hiccups, so I installed it recorded it in a GIF. So the first thing that we need to do is to use the install GitHub function from the DevTools package, and we give it the package URL, and it downloads the package, and then R will come back to you saying that there is these number of packages that you may like to update. If you wanted to, it will update it for you. Otherwise, it will just go on and install the package for you. Then I will quickly show you that we've included dummy data And then the whole purpose of the dummy data, which is documented as we can see here with the help file, is to allow users to test the functions and to review it if they would like to. And then the run Six Sigma model function, as you can see, it's documented with the help file. It tells you what parameters it expects, the arguments that it can take, and we've included included examples of how to use the function. You can see that it's being used by the dummy data that's available, and you can see here in the second example of the second set of code, it's going to call an API with the password and the username, and it successfully runs the model using remotely stored data, and you can see there are differences between the costs calculated by the dummy data and remotely stored data. We can also look at the run PSA function, and again, the run PSA function has, again, we've also included some dummy data for PSA parameter information of parameter distributions. This is the documented data, and you can see again, the run PSA is also well documented. It will tell you the parameters it needs, and again, we have example code within the package. You can use it. You can test the function using the locally stored dummy data, as you can see there. And we are going to call it for only 2 simulations or 2 PSA runs, and there it does it. And again, as I said earlier, using the get model params function, it will call it internally, and it will pass the name of or the address of the API together with the user or the path and the password, and it will do that for us. It will grab the PSA data and run the PSA locally. Great. So one last thing that I would like to highlight here and to emphasize the point which Rob earlier mentioned is that we would like to recycle the code. So we built the functions in a way that we can use in future projects. And that's why all the functions, except one in this package, are reusable and they are generic. So the only function that is not reusable for other models is the run Six Sigma model. It's specific to the Six Sigma model. It has some features in it. But the other functions, all the functions that are highlighted in red are generic, and they can be used in other functions in writing other models. And just to give you a trivial example, I've used the define transition matrix function here in order to to plot the diagram of a model. I'm passing it to the plot mat function from the diagram, and they got it. We have a different structure for a different Markov model. So if you're interested in the package, we obviously want you to go and play around with it. The link is there. It's the third from the bottom, and it's under the dark peak subdomain in GitHub. Thank you.
I'm just sharing the link to the package, and okay. So the link to the package is in the.
That's for the waiting room participants. Better to everyone. Just on the menu there. To everyone.
Okay. Everyone. Thank you. So the package is there, and the paper link I put on LinkedIn, and now I can't. I think where it is. Copy. So the paper that we'd really like feedback on is also linked to. So yeah, thank you very much. And do you want to welcome all to take questions if it's a couple of minutes?
Exactly. Any questions for Rob and
Wael
from the room? You can be the first one to use this.
I'm very. Hi, I'm Nicola. Thanks for that. Really interesting talk. I'm just wondering if, aside from the kind of confidence and testing of the functions, like what you think the main other benefits are from kind of turning a kind of standard script into a package. And also, are there maybe some negatives in that know, just speaking from my own experience, if I'm copying someone's kind of script code, I tend to understand a bit more what's going on in that function, whereas I guess there's a bit of a risk with a package that it becomes a bit more of a black box, and yeah.
Yeah, that's true. So I think other benefits, I suppose, once you have a package, it's kind of a self-contained package of functions. And so, for example, things like if you wanted to build a Shiny app, you can just call in the whole package, and then you have all the functions you need for your Shiny app. And so you've got one unit of one code base that's in one location that you can guarantee every time you call, if you install it and then call the functions, they're going to be the same. So you could have an application and a automated report and a script that all called the same functions, and you weren't kind of copying and pasting them between. In terms of downsides, I suppose I guess there's the overhead in terms of it's a new thing to learn. People can be put off by the fact that you're kind of continually testing. So as you write a script, you might just continue to write code, whereas in a package you tend to write code and then hit the test function and all the tests will rerun. And so that can be a bit off-putting when you're kind of starting again. But yeah, other than that, I don't know if you know of any other downsides.
No, I think that's the only downside that I would think about. But I think some of the benefits is that you can improve your functions from time to time, as in improve the efficiency of the functions, and then make sure that while you improve the efficiency, you haven't broken them, as in introduced a silent error into the functions. And this is guaranteed to some extent by the tests you've introduced when you started writing your functions.
There's another one there. So I think
There's two questions on.
Okay, so then we move on to the online ones. Go for it.
Yeah. Actually, just to follow up on that one, I would say there's a couple of your questions that maybe weren't addressed. There is no reason why you can't read the code. If you go and look on GitHub, the code is right there, just the I, you can go in and read it. And the other big advantage of packages is reproducible research. It's there, anybody can install it, particularly if you add on information about the environment that you built it in and that kind of thing, or you containerize it, then it's really simple.
Yeah, exactly. I mean, containerizing is a whole other topic. But yeah, containerizing is a whole other topic. But yeah, certainly huge benefit there. Probably further down the line for our industry, given that we're trying to get people to move from Excel. But yeah.
Right. Shall we move on to the online questions? I think that's that one.
There's one on Q&A and then one on.
All right. So on the last example with the transition matrix, if I had a larger model with more else states and cycle-specific transition probabilities, how would I go about reusing that transition matrix function?
Okay, so the defined transition matrix function that we've defined or introduced in this package is valid for any Markov model that does not relax the Markovian assumption, as in it uses static probability, transition probability matrix, where the transition probability matrix doesn't change, but it's not affected by the number of health states, if I got the question correct.
Do you want to read the Q&A?
Chat so they can read it.
All right. Okay.
Yeah, the CRAN question is, so the question is, do you see any advantages to uploading a package to CRAN versus just hosting on GitHub? So we've suggested just hosting on GitHub, and we've had this question from a few different people now at various talks. And so I've not submitted anything to CRAN. My impression is that there's a lot of extra time spent to make sure that it's kind of compliant for all the different reasons that are really important for kind of software development. The reason why we've kind of promoted hosting these on GitHub is that the key aim of this is just to provide the code open source to be able to build on. And so it's kind of a collaborative thing rather than necessarily really reliable software. So you can go and take the functions from a package, and as long as we kind of all have confidence in them, it's fine on GitHub. Does it need to go to CRAN? There's quite a lot of work involved in that. And would somebody do that if they're quite short on time? Probably not. So yeah.
I'm just wondering, maybe Chris Jackson, do you want to comment on this? The developer of Flex.
CRAN versus GitHub, you mean?
Yeah, for each individual, so if you had 10 different modelers working on 10 different models, would all of them want to submit that to CRAN, or is GitHub enough?
Well, I mean, it depends on whether I think whether the package is stable and whether you're continually changing it. If it's it's a self-contained piece of work that you're wanting to stick around for a few years and just do the same thing in the same way, then GitHub might be better. But CRAN is, I think it's more. It gives users confidence that it's been tested, validated, and it's a all those checks are a bit of those checks that you have to go through. They're a bit of a faff, but it's good for the users in terms of quality control. It gives them a reassurance that it's been through this process of quality control, and I think that's more beneficial if it's intended as a stable piece of software. But if it's an ongoing development process, if you're trying to refine, and I guess your end goal of an RHTA thing for regulators, if that's your end point, if that's going to be your stable thing that you're aiming towards, then yeah, it might be a good goal to get on CRAN eventually, I think.
Yeah, I completely agree with that. And I think the CRAN checks are nothing to do with health economics. The CRAN checks are just software checks. So just because something's on CRAN, you could publish something incredibly basic and completely wrong in terms of health economics on CRAN, but it would pass all the CRAN checks, right? Whereas, yeah, the
But
review.
there's still value in that.
Yeah. Sure.
Yeah.
But I guess the peer review
Yeah.
process from a health economist is what's really valuable, and you can do that on CRAN or GitHub.
Okay.
But yeah.
Excellent discussion. I think we should move on to the next conference.
Yes.